So we were on our last type of factoring. Let's real quick review all the types of factoring that we've done. Greatest common factor, which is what they all share in common. We did grouping, and I need the computers closed at this point. Grouping is when you have how many terms? Remember we grouped?
Wait, four.
Four. Grouping is for 4 terms. Good. We did our trinomials, which is the X box. Can you please shut the computer? That's now twice on my recording, so I'm unhappy about that. All right, we did the trinomials, which was your X box thing. All right, and then this is the last kind that we're going to do, which is called difference of squares. It is the exact same thing as a trinomial, but the middle term is 0. You are missing the middle term. It is 0. It has canceled out. And what you want to do is look for your perfect squares. Let's just make a list of our perfect squares so we can remember them. I'll get the list started and see if you guys can continue it here. We got 4, 9, 16.
30.
25 is the next one, and then 30 something. 36. Good job. Well remembered, guys. Let's keep going. See if we can get all the way to 100. 49 is 7 squared. 64. Nice job back there. 81 is 9 squared. And 100. They obviously go on forever. Numbers are infinite. Very nice. I'm proud of you guys for remembering them. So what you're going to do, and I'm only going to write this out for the first one. After this, I want you to just understand that it's 0. But this is actually a trinomial where your middle term is missing. So you can think of it as a squared plus no a's minus 49. So if you were to make an X box for this, and again, this is the only time I'm going to go through this process. After this, we're going to kind of jump this step and not do all the work. But I want to show you why this happens, all right? Negative 49 goes on the top. 0 goes on the bottom. So can you guys give me some numbers that multiply to be 49 that would add or subtract to be nothing? Yes, 7 and negative 7. 7 minus 7 gives you 0. That's why you want to think of those perfect squares. And so when you go draw your 2 sets of parentheses, you get a plus 7 and a minus 7, and that's your answer. So what these are going to do is they're going to be the exact same thing, but 1 plus and 1 minus, because that will give you 0. All right, let's try it again. Do you notice how the middle term is missing? And 64 is a perfect square. Those are the things you've got to notice. So we're going to put X in both of these. One's going to be plus and one's going to be minus. What? No, good. Why do you think 8?
Because 8 squared is 64.
8 squared is 64. And 8 minus 8 is 0. Good. That's your answer. All right. How about this one? What do you think for 9? Yeah, one's going to be negative 3. And then one's going to be positive 3. 3 squared is 9. 3 minus 3 is 0. Now, they can be a little bit more complicated, but do you notice how 25 and 36 are both perfect squares? Okay. So when you split it this time, what's your square root of 25? Again, you want the same number in both of them. 5. So it's going to be 5k and 5k. 5 times 5 is 25. And then what about 36? 6. One is going to be positive and one is going to be negative. They should be identical, but 1 plus and 1 minus, because that's how you cancel out and get 0. You guys are all being very quiet, which is awesome, but is this making sense? Like, are we, it's okay. This is one of the easier ones that we do. Now this one, there's one extra step. This would be your multi-step factoring. You have to do a greatest common factor first. What divides from both of those? 3. Perfect. Nice job. Put a 3, put a parenthesis. We're going to divide them both by 3. It is like undistributing a 3. You are distributing except backwards. All right. So what do you get left with in the first? Yeah, just the x squared. Good. 12 divided by 3 is 4. Now that 3 is just there. It is just there. I do not have a better explanation than it is just there. And you're going to take this x squared minus 4 and do the exact same thing that we did in those couple of other problems. So what do you think about 4? What's your square root of 4? 2. Good. So it's going to be, and I've got your pass in, you can go ahead and go. You're good.
Can I go back?
All right, so it's going to be x What'll go in the first one? You already told me it's 2, so the first one will be +2 and then -2. 2 minus 2 is 0. All right. This one, again, you have a greatest common factor. What can you divide both of these by? 5. Now, there's actually something else there that they have in common too. What else do they both have? N. They both have N. So 5N is your greatest common factor. Stick with me here. This part shouldn't take too long, and then we can have time to do a game later. All right, you're going to divide them both by 5N. 45 divided by 5. 9. Good. Now, good. Why is it N squared? Why do you have 2 of them? Because that is correct. It's cubed. Yep, 3 minus 1 is 2. All right. Minus, now this is a little tricky. Oh, maybe it's not. Why is it 1?
Because
5 divided by 5 is 1. Okay, cool. The 5N is just there. We're going to split this. Now, 1 does mess people up because what's the square root of 1? 1. Perfect. How would you split 9? Good. You got 3N and 3N. 3 times 3 is 9. And +1 minus 1. Good job. That's a really hard problem, and that didn't really stumble you guys at all, so nice job. How many more of these? Yeah, we'll do a couple more, and then I'll give you a break, all right? 25 and 4. Do you notice that they're both perfect squares? You have to be a good noticer, is really all this is. So draw your 2 parentheses. How would you split up 25? Yep, 5. 5 times 5 is 25. Now the X is in the second one. That's fine. It's just reversed, all right? So how would you split up 4? 2. So it'll be 2x because the X was with that one, and plus and minus. Again, the plus and the minus is how you cancel out and get 0 in the middle. The middle term is missing. All right, this one has a 1 in it. 1 can be tricky, but when you split 1, it's just 1. 1 times 1 is 1, is kind of what happened there. All right, how would you split 16? What's your square root of 6? Good, but it's going to be 4x. Good, because the x was in the second term with that one. It can be in whatever order. And then what symbols am I going to put? Yeah, plus and minus. That's how you cancel out and get 0. Cool. Again, this is like one of the easiest ones we do. We'll do these 2 and then we'll do a break. All right, I noticed that these numbers are kind of big. I need to know what goes into both of them. If you know, it's really cool. If you don't, let's review how to type this in the calculator. Remember what you typed to get it to give you greatest common factor. I kind of just said it. CF, remembered. And what are the numbers? 18, 128. 2. We'll do numbers, it just won't do variables. So we're going to put 2, put our parentheses. We're going to divide them both by 2. You are undistributing a 2. Still with me over there? All right. 18 divided by 2. So 9x squared. Good. Minus. Oh, good job. Nice. Calculator in your brain over there. All right. The 2 is just there. I don't have a better explanation for that. You need to notice 9 and 64 are perfect squares. So how would you split the 9x squared? So it would be 3x. 3x. Again, you want them the same. And then 64 be plus 8 minus 8. Good job. They should be the same thing, but plus and minus. All right, well, let's try one more. You need to notice 36 and 49 are perfect squares. Oh, but there is something they share in common. What if they good? They both have A. So we're going to take out an A. We're going to GCF A out of there. Take out A. So that would leave you with 36 what?
A squared.
A squared. Good. 3 minus 1 is 2 is really the only math we did there. Minus 49. Good job. This is going so well. So the A is just there. Draw your 2 parentheses. And then how does 36 split? 6. So it'll be 6A. Good. And 6A. Sorry, that's a bad A. Let me rewrite that. And then 49, 7 and 7, and then 1 plus 1 minus. So these ones say solve for x. Notice that there is an x in both of these terms. So that is your greatest common factor that you're going to factor out. So what you're going to do is put x, put your parentheses, and you're undistributing the x. You're taking the x out. So what's left? A plus b, kind of just the other stuff that's there, equals 2. Good job. There's only one more step to get x by itself. Perfect. X is being multiplied by all of this. So we're going to divide by a plus b to cancel it out. If something is being multiplied, you divide. If it's being divided, you multiply. You're just doing the opposite thing there. And then this is your answer. You can rewrite it if you want to, but it's not really necessary. Do you see how x is by itself now? Yeah, I mean, you can rewrite it if you want to, but not really necessary. Let's just try that again. Shh. We were so focused before. Let's keep it up. Do you see how both of these terms have an x? Okay. All you're going to do is factor it out. You're going to undistribute the x. Basically, just remove the x from both of the terms. What will that leave you with? Yeah, 3 minus p was y. Basically, like alphabet soup here. Right? Then your last step to get the x by itself, you're going to divide by the 3 minus p. X is now alone. You can rewrite it if you want to, but it's not really necessary. That's your answer. Okay? You guys, I know, if you listen to me, are you guys okay back there? Just checking on my quiet people. All right. Let's try it again. For this one, you have an extra step. Do you see how the x's are not on the same side? Okay, so the first thing you have to do is get them on the same side. How could I do that? Subtract is correct. I'm going to subtract px. Again, they're just letters, just like alphabet soup here. So that's going to give you 7x minus px equals n. Now it's exactly like the other ones that we did. Do you see that? You just had one extra step where you had to slide that over and get them on the same side. So what would we do next? Yeah, good, perfect. Take out the x. That leaves you with 7 minus p. Your paper's right there if you want to write any of this down. Yeah. No. All right, and then you're going to divide by 7 minus p. And you can recopy the whole thing if you want to, but it's not, again, not. All right, last one of these. We need to slide things around so that the x's are on the same side. So how could I do that? I want to get the x's on the same side. Well, I am going to do that too. Actually, we can do that first since you said that. We're going to plus the 3 to the other side. Well, you can't, 3 and doesn't have a b with it. They're not like terms, so you can't combine them. You're going to basically just leave it alone. It's just going to be ax plus b plus 3. None of them are the same. They're all separate. Yeah, and then we have to get all the x's to the same side. You're just moving, algebra is just moving stuff. You're just like, I'm just going to move this over here and move that over there. So we're going to subtract the ax to the other side. So it'll be 5x minus ax equals b plus 3. Again, basically the only way you're going to mess it up is if you do anything. You're just going to leave everything alone. Now it's back like 11 and 12. So what is your next step? Since they both have an egg. Yeah, like factor out the x. You're dividing the x out of both of them. Which will leave you with 5 minus a. This is just rearranging. Just like a little puzzle where you rearrange all the variables and numbers. And then what's your last step? Yep, divide by 5 minus a. I knew what you meant though. And then this is your answer.